Hi Calc AB, this is 3.1 day 4. So this is an extension of chain rule, and it's when you can use tables and also graphs. I don't give examples of graphs here, but you would do this exactly the same way with graphs as you would with tables. So number 1, assume g is a function such that g prime exists for all x. Find f prime. Leave your answers in terms of g and g prime. So letter A, B, and C give various ways that we could talk about a function and then how a cube can be related to it. So like in letter A, this is a product. So I'll use product rule. First function times the derivative of the second plus the second times the derivative of the first. Nothing there is a chain. This is just straightforward product rule. Part B, this is a chain rule situation because the outside function is a power and the inside function is g. So f prime is going to be equal to the derivative of the outside function times the derivative of the inside. And letter C switches it up, so x cubed this time is inside and the outside function is g. So the derivative of f is the derivative of g times the derivative of the inside. So I give these three examples to show you that they all kind of look the same, but each of them are approached differently. So like the first one is a product rule and the second two are chain rule, but even how you approach the chains is different because you have different functions being on the inside and the outside. All right, number 2. So we have a table and it's full of f prime, g, and g prime. And so we have all of these different functions here that use f and g in different ways. So h is equal to f of g, therefore h is equal to f prime of g times g prime. And that's because this is your inside function and f is the outside function. And now we have to plug in 2. So h prime of 2 is f prime of g of 2 times g prime of 2. So g of 2, you look at your table, g of 2 is 3. G prime of 2 is 4. And f prime of 3 is also 3. So 3 times 4 is equal to 12. Now one other thing, if I were to extend this to graphs, like it's nice that the table gives us all these values, but if I were to extend this to graphs, remember that these primes represent the slope. And so really the only way that I can give you a graph and ask you to find slope is if I give you linear segments in which you could just count like the up and over for that particular situation. All right, part B. M is equal to g of f. So this will be g prime of f times f prime. M prime of 3 is g prime of f of 3 times f prime of 3. And now we can figure that out. So f of 3 is 4 and g prime of 4 is 1. So this turns into 1 times f prime of 3. Letter C. K equals f of 2x. So it looks a little different than the other ones, but just remember that that 2x is the inside function. And because it's different than x, you do have to work with the chain rule. So k prime is equal to f prime of 2x times 2. This tends to be the thing that most students forget when they're doing this, but the derivative of a line is equal to that coefficient on the x. So k prime of 1 is f prime of 2 times 2. And now we can plug in. So f prime of 2 is 1, so our answer is 2. And letter D. The g function is the inside one, and the cube is the outside function. So q prime is equal to the outside power, derivative, times the derivative of the inside. Q prime of 3 is 3 times g of 3 times squared times g prime of 3. So now we can plug in these numbers. G of 3 is 1. G prime of 3 is 2. So our answer is 6. And letter E, straightforward product. So this is really a recap of what we did in our last chapter. And recognize that you don't need chain rule, that now we're just adding to your toolbox of rules, and you can't forget all the things that we've learned before. So B prime of 1 is F of 1 times G prime of 1 plus G of 1 times F prime of 1. And now we just plug in our numbers here. So F of 1 is 1 and G prime of 1 is 3. So 1 times 3 plus 4 times 2 equals 11. So that's it. That's it for chain rule. And it's really like a hodgepodge day where you have to be able to plug in numbers. And we'd want you to come up with chain rule in various ways and also recognize that it can be different from product rule or quotient rule. So now you guys have some homework to do. Bye.